This video is about how to find the domain of a function. So our goal is, after you watch this video, that if I give you any function, that you would be able to state what the domain is. So there's an example right there with an input of x, an output of y, and a square root. So let's look at a simple example. Here's an equation. Domain is a list or a group or a way of describing all of the possible inputs. So I think personally it's easiest to start with a list. So we're going to say possible inputs, and then we think, okay, what can we put in to this function? Now the input is x, so I think, okay, well, can I put 1 in for x? That's the same thing as asking, can I take 4 times 1? Well, sure, I get 4 out. So 1 is a possible input. And, well, can I do 2? Well, sure. 4 times 2, I can do that. Can I do -3? Well, sure. 4 times -3. Now, so far, I'm sure you're thinking this seems pretty silly. But we will get to a little bit more complicated examples later. Well, now, is this a complete list? Well, no, there are lots of things that I do not have on my list yet. And it would take me forever to actually list everything, because there's 3, there's 4, 5, 6, 7, those all work. -17, pi works. You can take 4 times about 3.14, that would be fine. So this list will never be complete. So I start with a list, but this isn't the best way to write my answer for this one. My possible inputs are anything, really. So the domain is anything. And how I like to write this is with inequality symbols. And since domain deals with x, I use an x in the middle of that sandwich there. So I always start like this. Now what I need to do is put a number here, right above that blank. That number would be what x has to stay above. And then I put another number over here, and that's what x has to stay below. Now in this case, there aren't any limits. For example, I could go down to -5, -17, -1,000. So there is no lower limit for this. Erase this to give myself a little more space and make it a little more clear. This goes down, negative, forever. And that's a symbol for forever. That's the infinity symbol. Maybe you've seen that before, but basically an 8 on its side. As you can see, I have difficulty drawing the loops the same size. So this is what I had here before. The x with the chompers on either side with the inequality symbols. And then I think, okay, well, what's the biggest thing I can put in for x? Well, the biggest thing I have on my list is 2, but 3 works, pi works, 4 works, 1,000 works, 1,000,000 works. So there's no upper limit, so it goes up forever. So you put an infinity symbol there. There is no upper limit. Now again, I'm sure you're thinking this is pretty silly because, okay, well, when would there ever be something where you could not put something in? Well, there are lots of functions like that. Here's one example. Y equals the square root of x. So the first thing I'm going to try is to make a list of everything that works. So the list of everything that works, domain, those are the same thing. Domain is just a fancy way of saying that. So I think, okay, well, what can I put into this function? Input is the x, so can I put 1 in, just for example? Well, sure. You can take the square root of 1. If you try that on your calculator, you'll see the output is 1. Let's see, what else should I try? Well, let's just keep counting up. 2. Can you put the square root of 2 in your calculator? Absolutely. It gives you a decimal answer. It never ends. It can't possibly write all the decimal places, just like pi. But if you put it in, you get a decimal, 1.41, blah, 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 blah. So 2 is a perfectly acceptable input. How about 3? Well, sure, you get about 1.7. 4, yep, you get an output of 2. 5, sure. 6, sure. When is this going to end? And does 5.7 work? Can you take the square root of 5.7? Better type it into the calculator to make sure. Well, yes, it's okay. I mean, I certainly get a very strange decimal as an output, but I get a number. And that makes sense. There is something squared that gives me 5.7. So I don't know about you, but I feel pretty confident that no matter how big the number, it would be fine to put it in to this function. If you're not sure, try a million. What is the square root of a million? If you've tried it, square root of a million is 1,000. Perfectly acceptable. But there are a bunch of numbers that I haven't tried. I've tried decimals, I've tried whole numbers. What about 0? I want to make sure that you're trying a whole bunch of different types of numbers. Yes, 0 does work. When you type in your calculator the square root of 0, it gives you 0. And that makes sense since 0 times 0 still equals 0. Hopefully you see where I'm getting at this. What about -1? Calculator should say error. Calculator saying error is just like you saying you don't know. It's not an answer, it's just saying, sorry, I can't help you. But the reason why it's confused is if you put in -1 into this, you're going to get, okay, well, it's y equals the square root of -1. And then we're asking ourselves, okay, what number times itself gives me -1? And there really is no number that makes that happen. There is no real number for which that is possible. So -1 is not in the domain. What are some other numbers that are not in the domain? Hopefully it's pretty obvious to you at this point that, well, how about -4.837 or -6 or, okay, any negative number. So hopefully you have a pretty good idea in your head of what the domain is. We just have to have a way of writing it. So I'll get kind of lazy here and just put a D for domain. And once again, I cannot make a list because the things that are in the domain, it would take me forever to list them all. I mean, you can see a couple there, 1, 2, 3, 4, 5.70, but I missed quite a few. 7, 142, pi. Hopefully you're pretty confident that for the upper limit, there is nothing that is too big to be put into this function. I could put in 1,000,000, I could put in 10 million. So I put the infinity symbol on the upper side to say that, well, there's no limit for how high x can go for the domain for this. On the other hand, there is a limit on the low end. The place at which we start to have a problem is right where 0 and -1 are at. 0 is fine, but -1 is not. How about -0.5? I didn't try that. How about -0.2? If you try even those decimal negative answers, you'll see that those don't work. So the last place that it works is 0. And to say that 0 does work, I put a line below so that I'm telling you that x could be equal to 0. It has to be bigger than it, or it could be equal to it. And then there's no upper limit, so I keep that less than infinity, which basically means no. All right, let's do another less simple example. We haven't done any graphs, which I think is a bit easier. So here's a graph. I'm going to start it right here. This will be a ray where it starts at one point, or an arrow, and then it kind of grows from that. So it starts at that point that I've labeled there, but it does have an arrow that means it keeps going in that direction. So again, you can start making the list. What works for the input? Well, How about 4? Is there an input for 4? Why, yes. That point right there has an input of 4, and the output is, I don't know, it looks like 4. But the input of 4 is 5, and so is 5, and so is, well, pi, about right there. That point has an input of pi. And 7, and how about 10? Well, yeah, sure. Even though I didn't draw it, this graph keeps going, and because of that arrow, it says it's going to keep going in that direction. So certainly 10 would be a fine input. I'd have to continue the graph to be able to see what the output would be, but it seems that that is fine. What is not in the domain? Well, how about 0? When I put 0 into this function, you'll notice there is nothing on that portion of the graph. And what I'm talking about is right at the beginning there. Right where the y-axis is, so it's this part that I'm highlighting in green right here. There is no output anywhere on that line because all those have an input of 0, but there's no output there. The graph doesn't go that far. So 0 doesn't work. What else doesn't work? Even 1 or -5. And those are all things that there's nothing written on that left side of the graph there. So I think I'm about ready to say what my domain is. What's the upper limit and what is the lower limit? Well, the upper limit, there isn't one. So I say it goes up forever, the infinity symbol. There is a lower limit. The lowest thing I can put in is 2, it looks like by my graph. Certainly not super clear, but on this one it looks like the lowest input is 2. And it looks like it does reach 2, so I'm going to put a line below to say that yes, x can equal 2, but it can't be 1 or 0 or anything lower than that. So that's the domain right there. Anything 2 and above is another way to write that. All right, now's the time for you to try some on your own. So try that one as number 1. Number 2, start with a graph. That open circle there means that the graph goes up to that point, which looks like it's -3, 1, but it never reaches there. It goes up to it, but doesn't reach that. And the last one, number 3, is 17 times the square root of x plus 4. What is the domain of that? So go ahead and pause the video and try this on your own. And once you've finished and have some guesses for your answer, go ahead and press play again. Okay, let's go ahead and see how you do. For the first one, you certainly don't have to try to make a list first, but personally I think that's the easiest way to do it. So what kinds of things are in the domain? And then below it I'll just, if I run into anything that doesn't work, I'll put that in the lower list here. So let me go back and look at the function here. It was the square root of x minus 5. Okay, so I don't know where you normally start, but I normally start with lower numbers like 1. If I try to put 1 into that, I get the square root of 1 minus 5. I have to do the inside of the square root first. So 1 minus 5 is -4. And if you try to find the square root of -4, there isn't really one. So that didn't work. So the problem was the input of +1. +1 did not work. I tried to put it in, and I did not get any output. It didn't work. All right, well, how about 2? Well, take the square root of 2 minus 5. That's the square root of negative 3. And again, since we have a negative on the inside of a square root, it doesn't really make sense. So 2 also doesn't work. So I don't know about you, but I think maybe I should try some negative numbers here. See if that works. So looking at y equals the square root of x minus 5 still, let's say I'll try negative 1 to put that in. That's the square root of negative 1 minus 5. Negative 1 minus 5 is negative 6, and then when I try to take the square root of that doesn't work. So, okay, now I'm running into a brick wall, even with negative numbers. So I've tried positives, I've tried negatives, a little bit confused here. So far I think nothing works. But I do need to keep trying things because I don't have a complete picture. Hopefully you came upon this without too much trouble. But if you try to plug in 3 minus 5 is negative 2, the square root of that doesn't work. 3 doesn't work. 4 doesn't work. But 5 does. When you plug in 5, you get the square root of 5 minus 5. 5 minus 5 is 0, square root of that. Square root of 0 is also 0. So that's why 5 does work. Now if you try something like 4.9, it doesn't work. So maybe I'll try something higher than 5. Okay, so I plug in 6. Square root of 6 minus 5. That's the square root of 1. Square root of 1 is 1. So 6 was also a fine input, one that works. It's in the domain. So hopefully you're ready to make a list or a complete description of what does work. So far I just have a partial list. So the lower limit is 5. That's the lower limit I can put in. It could be equal to 5, so I put that line below the less than symbol there. And there's no upper limit. Hopefully you realize that because you've tried 7, 8, 9, 10, 1,000, 10,000, something like that to get a picture of this. All right, number 2. Looking at that graph, there are a number of inputs that do work. Like 1, it's right here. That has an input of 1. 2, 1.5. 3, an input of pi right there, an input of 4, input of negative 1. There are lots of things that work here. I'm going to skip making a list for this one, but for number 2, the domain well, what's the upper limit? There isn't one. Keeps going forever. It won't happen every time. It's just been happening a lot with the examples that I have here. It goes up forever. What's the lower limit? Let me go back and look at the graph. The lower limit is right here. That's the place where it ends. And it looks like the input for that is negative 3. And maybe the output is 1. So that hole right there, that point that isn't part of the graph, is negative 3, 1. So, domain, the place where it stops is negative 3. Negative 2.9 was fine. That was right next to that dot, and that's still okay. Now, negative 3 does not work, so I don't put a line underneath here. That's incorrect. I did not want to put that. Because it does not actually reach negative 3. All right, let's look at the third one. Third one was another equation. So think about, okay, what can I put in to that? And again, I'm going to skip the list, but if you tried 1, it worked. Try and input 1 at 17 times the square root of 1 plus 4. You do square roots because they're the same thing as exponents first. Square root of 1 is 1. 17 times 1 is 17, and then plus 4 is 21. So that's fine. 1 works. 2 works. 3, 4, 5, a million. Those all work. How about 0? Sure, 17 times the square root of 0 is fine. Plus 4 still makes it okay. The negatives are where you run into an issue. So for this one, the lowest thing I could find that worked was 0. Anything lower than that, and I was trying to take the square root of a negative number, and that didn't work. 0 does work, so I put a line underneath there to say it's the lowest thing, and there's no upper limit, so it goes on forever. So So how do you feel about domain now? I do feel like it's one of the most complex of the topics. I'd say the average person, this might take you a month or so before you really feel comfortable with this. That was certainly the case for me. This one was a really tough one. So if you're lucky, after this video, you already understand domain. I'm not expecting most of you to, but this is a hard one. Can you state the domain of that function right there? I think I use that as one of my examples. If you can, great. If not, get some extra help, ask a friend, find another YouTube video, find a website, whatever it takes for you to be able to